let me just I will create a node project where I'm going to put some comments and everything there, so that will be easier to follow. It's taking some time. JKUAT. Okay, so I just created a folder which is empty, and then I open this folder in VS Code, and as you can see there is nothing. But the first thing that I want to create is maybe a README file just to put some comments. It's taking some time to load. Yeah, perfect. Okay. So the first thing, maybe let's put accounts. So we'll have the accounts, and then an account will always have a private key, and then it will always have an address. So as you can see, I just created an account in MetaMask just by clicking here in the accounts, add a new account, and then I was able to just put a name. In this case, the name of my account is called JKUAT, and then I have an address. The address is this one, so I will just copy my address. And then my private key, to access to my private key, you will need to click here in these three dots, account details. Oh, here you can see the address again, but then you can click in show private key. You put a password, because when you install MetaMask, you will need to put a password there. You confirm, hold to reveal your private key, and then this is my private key. You are not supposed to show your private key like never, but this is a testnet account, and yeah, this is a workshop, so that's fine. But yeah, sharing your private key, sharing basically access to this address, and everyone will have access to your funds. So right now this account has 0 Sepolia ETH. Remember that Sepolia ETH is the token used in the Sepolia testnet. And now I'm going to send some funds from this Vault account to the JKUAT account. So the JKUAT account is the one that I'm going to use today for everything. This is taking some time. Let's see. Okay, this is not clicking. Okay, Vault. Then I will send to JKUAT. I will send like 3 ETH. Oh, it's not working. Because we will need testnet tokens to be able to deploy contracts. I don't know if this is working or not. Yeah, anyway, for now, okay, so that's the first thing of Ethereum. We will always need to have an account to do whatever that we want to do, to interact with contracts, to deploy with contracts. We always need an account. Do you guys have any questions with the accounts, private keys and addresses? Is that part clear? Perfect. Never share your private key, don't forget that. Let me just see if I can send the funds to JKUAT. 3. Okay, so I'm going to send 3 tokens, like 3 ETH Sepolia, because we will need that. Okay, it's taking some. Oh, the internet is not working. Yeah, that's why. Maybe because the internet is not working, it's taking some time. Gideon, are you able to share internet? Okay. Yeah, because it's not working. That's why. Yeah, we always need internet to be able to connect to the blockchain, so that's why it's not sending the tokens. It's working. Yours? What's the password like? Well, which one? Okay, so let me just try again. Okay. I guess now it works. So here we are sending the transaction, and then there is something called Block Explorer. Who don't know what is a Block Explorer? Okay, perfect. So the Block Explorer is basically where we can see what's happening in the blockchain, because this blockchain is, as Gideon says, just like a bunch of computers agreeing on something. So right now what they are agreeing on is that they are agreeing that for my Vault wallet I send 3 ETH to my JKUAT wallet. So all these nodes are kind of agreeing and validating that this is true. And then if we want to see this, we can go to a Block Explorer and we will be able to double check that this happened, that this is true. But let's see, because we need internet to access to the Block Explorer too. But it's not working. Yeah. I don't know why. So yeah, I wanna give you a short introduction to the Block Explorer too, but let's see if this works. Yeah. Okay, so what happened is that when we send transactions, okay, there are 2 things that we can do with the blockchain. Just 2 simple actions. We can only send transactions or fetch data, right? So in this case, what I did was that I sent a transaction. I sent 3 tokens from one account to the other account. And then when we send transactions, we have something called transaction hash. This is kind of like a receipt that we can check in the Block Explorer. And then right now I'm the Sepolia Etherscan Block Explorer, and we have all this information. The first thing is the transaction hash. So this is the, let's say, the receipt number of the transaction. Then we have the status is success, the block. Remember that the blockchain is called blockchain because it's just like a bunch of blocks that are minted in Ethereum. The blocks are minted every 12 seconds. Here we have the timestamp, like the time that the transaction was sent. Then we have the from account. This from account was my Vault account that I have in MetaMask. And then this 2 account was the JKUAT account that I just created. And then I sent 3 ETH. So basically this is the information of the transaction. And the Block Explorer is useful because you can confirm all these things. That's why always you see with all the blockchain maximalists that they say don't trust, verify. Because you don't need to trust me that I send you 3 ETH. You just come here and you can verify that I send you 3 ETH, right? So that's why that's something really important to understand the Block Explorer. Then here we have the transaction fees, the gas price, just kind of other more advanced things that we need to understand that we need to pay fees. In this case, I paid 3 ETH, but then I also paid this for fees to those validators that are kind of validating the network. Do you guys get this part of the transaction hash and the Block Explorer? Do you have any question with this? Is it clear? Yeah? Okay, perfect. So yeah, now if we check my JKUAT account. Oh, for the internet. Oh, but I don't have I think I don't have this thing. Yeah. And then let me check. Then if we check, okay, the Block Explorer is really good because we can just search here by addresses, transaction hash, blocks, etc. So if I come to the Block Explorer and I copy my address, remember that is this address too that I have here, and then I paste it here, we can see the balance of my JKUAT account. But the internet is not working now. Oh, okay, thank you. Let's see if this works. This function set message, and then external, and then this function will receive a parameter which will be a string, and then let's call it new message. And then the only thing that this function will do is to update this message variable here in line 8, message equal to new message. Do you guys have any questions so far with this thing? I like to stop and and just check if you're the same page. It's clear, these two functions? Yep.
So, like for example, if you know about object-oriented programming, so a contract is like a class, and then you have like the methods that you use within that class.
And the variables are the properties.
The properties of
Yeah.
that particular class.
Yeah, it can be like that. So this is the variables, and then these methods will, the only thing that these methods will do will be to interact with these state variables. I mean, when you get like more deep and advanced into Solidity, you can also interact with other smart contracts from these functions without even interacting with these variables. But yeah, but for now, this is something like that. And a class with properties here, and then the methods here. Perfect. Any other questions? Okay, so now if we deploy the contract again, we will see that we have these two functions. Get message, that I can click here, and then we get the string nothing, and then the set message that will receive one parameter that is the new message, right? So if I put, let's say, hello JKUAT, and then I click in transact, when I click here, I'm sending a transaction to update this state variable. That's why we need funds, because we are changing this message from nothing, right now is empty string, to this hello JKUAT. So if I click in transact, and then if I click again in get message, we will see that the new message is hello JKUAT. And then if I click again, and then I put more of this, transact, get message, now we have this new message. So is this clear, this is smart contract so far?
So the more you're clicking the get message, the funds are reducing.
No, because get message is a good question. Get message is a reading function, and when you use reading functions, you don't need funds, because you are only kind of indexing, you are just fetching data. So every time that you want to fetch data, you don't need funds. But every time that you are interacting with writing functions, you need funds. That's a good question. So look, the difference is that these are external view return functions. So these are the reading functions, and this is a normal writing function, because we are updating this message. So because we are updating this message, we need to pay for it. But this one is only returning the message, so we don't need to pay for that. So if I click, if I click in hello JKUAT, we are getting, I don't know if we have the cost of this transaction here. Yeah, we are paying the gas, transaction cost, execution cost. So that's what we are paying for that, for updating the message. But then for the get message, we don't really need to pay anything. I can have zero, if you have zero funds, 0 ETH, and you try to set message, it will get an error that is not updating because you need to pay. But if you have 0 funds and you click and get message, it will work. Yeah. Any other question with this? Perfect. So now what we can do, I think, today we can just write some smart contracts, deploy this on, like we are testing this here, then we can test, like deploy to a real testnet, and then we can see that in the Block Explorer, and I think that will be fun. Okay, so now let's deploy this in Sepolia. So remember that we will need some testnet tokens, and we are going to deploy it now to the real testnet. Are you familiar with the constructor? Do you know what is a constructor? Yeah, okay, the constructor, let me just write it here as well, just for you to understand. The constructor is a function that is only deployed is only called when you deploy the contract. So when you click here in deploy, we only deploy a contract one time. Once it's deployed, then the contract is living in the blockchain and it's already there. It will be there forever. So all the contracts that I deployed like 2 years ago, they are still there and they will be there forever. And the constructor is only called one time. Like you can see that now I can call the set message or get message as many times as I can, but the constructor is only called when you deploy the contract. So let's say that when I deploy this contract, I wanna set this message to, this is the message from the constructor. Okay, so what I'm doing here is when I deploy my contract, this will be the first message. And then we can get the message, and now we are not getting an empty string because actually we updated the message with this string here. So let me just deploy again. and then if I deploy, and then if I check the get message, we are getting, this is the message from the constructor, and then I put hello JKUAT, set message, and then if I get message again, we get this message too. So is the constructor clear as well? Of course, the constructor can also receive a parameter in case that you just don't want to hard code this and then you want to put a message here. You can also do that. And then when we try to deploy here, now it's asking for a parameter here that will be the new message. So we can say new message, deploy, and now we got that. That new message here. Perfect. But yeah, for the purpose of this, let's just hard code this first message, and then let's remove this. Perfect. So is this smart contract clear for everyone? Yeah, the contract only, we have the license here, then we have the compiler version, then we created this contract object here with one property or state variable, which is a string, where we are going to store a message. The constructor is updating this message when we deploy the contract with the first message string. And then we only have two functions. One function that will retrieve the message, which is a reading function, so we don't need funds for this one. And then the other one, which is a writing function, which is the set message, which can update the message state variable that we have here. So how can we deploy this to Sepolia testnet? We need to change the environment that we have here. Instead of Remix virtual machine, we can click in injected provider, and then this will connect to MetaMask. So right now it's just connected to my Vault account because I have 366 ETH, but I will disconnect that and I will connect it to my JKUAT account. So let me just come to JKUAT. So if I click in injected provider, MetaMask will pop up and will ask like, hey, do you want to connect your accounts to Remix? And then I will select the JKUAT account here, which has 3 Sepolia ETH. Then I click in next, confirm. And now you can see that my account is connected here. And now we are connected to Sepolia, which is that testnet network. And then if I click in deploy, this will not deploy down here, but it will actually deploy in Sepolia. So if I click in deploy, MetaMask will pop up here. Here we can see there is a contract deployment, the transaction that we are sending. These are the fees that I'm paying for deploying this contract. I click confirm. And now if we go back to the Block Explorer and we put the address of my JKUAT account, you can see that now my balance is 2.9906, and before it was 3 because we just deployed the contract and we needed some funds. And let me just here is going to show in a few seconds the second transfer. This was the first transfer that we received, 3 ETH here, but now it will show the contract deployment that we just deploy a contract. So let's refresh. Yeah, so then as you can see, 32 seconds ago I just deploy a contract creation, and then if we come to the contract creation, we will see actually the contract that we just deployed. So this is the address of the contract. Let me actually put it here as well. Address of the contract. So everything in blockchain is about addresses, and look that this one is a different address from the wallet. So this is my wallet address, and this is my contract address. Perfect. Because we just deployed, so this address was just created 1 minute ago when I deployed the contract. Any question with this so far? Perfect. And then what I'm going to do is to verify and publish the code of the contract. So when people interact with this smart contract, they know what are they interacting with. So to verify the contract, you come to contract, verify and publish. Then here is the address of the contract. This is a single file, the solidity code. The compiler version is 0.8.0. and the license is the MIT license. We continue. I will come to Remix. I will copy paste all the Solidity code. Then I come here, I click, I copy paste everything, and then just verify and publish. Okay, and now you can see that the contract was verified. And now when a contract is verified, you will see this green check here, and then you can see the code of my smart contract. So when you are interacting with a smart contract, it's always recommended to interact with a contract that is already verified, so you can see the code. And then you can see that the code of my contract is only this. It has a string message as a state variable, the constructor, and these two functions. And then we can see here two types of things in the Block Explorer, two buttons. One is read contract and one is write contract. Right now this contract is living in the Sepolia testnet, and if I click in get message, we are getting the first message that was initialized in the constructor when we deploy the contract. And then if I click in write contract, it will ask me to connect the wallet because we are sending a transaction. So in this case, let's say I will put this is the second message, and then I cannot click in write because I need to connect my wallet. So I will click in connect to Web3, okay, MetaMask, and now I just connected my account, but let me see which account I connected. Oh yeah, I will connect the JKUAT account. I'm going to show you also with web3.js how we can connect to a React app, MetaMask, because that's a really useful thing, but after doing this. So if I click in connect to Web3, it will ask me to choose MetaMask, then it will ask me to choose an account. I'm going to choose this JKUAT account. And now we can set the message. So I will say this is the second message from JKUAT account. And then if I click in write, MetaMask will pop up, will ask me to confirm this contract interaction, which is set message. Confirm. If you click in view transaction, you are going to check what I showed you before about the transaction hash. So this is the information of the transaction details. The transaction hash is not confirmed yet. Then it was from JKUAT account to the smart contract. We are not sending any value in this case, any transaction. Now let's refresh. Okay, and now it just succeed. So if I click in read contract again, now we have this is the second message from JKUAT account. Is the smart contract part clear? Because now I'm going to jump into the JavaScript, create a React app to interact with this contract. So that will be like more fun to see that. And then after that, I'm going to just, for the ones that just came, I will just start again doing a different contract, deploying the contract, and then creating a dApp again for that contract. But yeah, is that clear, the part of the smart contract so far?
Yeah.
Perfect. Okay. So now let's go to this folder. I'm going to create a React app, or maybe a Vite will be faster. Can I start here? Okay. So let's create this Vite app. Say message contract React JavaScript. So now I'm going to show you how you can use web3.js to interact with the blockchain, in this case with this contract from a front end. So you will be able to start creating apps only by using JavaScript. So yeah, this little part, this little logic of Solidity, you don't really need to even know this. At the end of the day, you will only need to know the contract address. I'm going to show you the contract address and then the different functions of that contract. In this case, we know that this contract has two functions, the get message and the set message. And we don't really care about how is that working under the hood. And to create the dApp, we only need to know the two functions that we are going to interact with. So let's see if this work. Okay. Actually, let me use this one. Yeah. Okay, so then we have this app. We are going to create maybe 2 or 3 dApps today. So the first dApp is called message contract, npm run dev, I think. So this is what we have by default, right? I'm going to remove some things here to have it a little bit more clean. Maybe this P, this P2, right, and React. Let's put it message contract. Okay, and then we'll have 2 buttons. One button will be, let me remove this. Maybe let's start with get message. Okay, get message. So far the only thing that I changed, I need to create the function here. Okay, so far the only thing that I did was to create this button. This button is calling this function get message that we are going to implement now to get the message of this contract that we have here. So if we call this from the front end, we are supposed to receive this message, right? So let me show you what we need to do to get that message. So the first thing will be to install web3.js. Maybe let me put it in this readme, like the steps to interact with contract in your dApp. npm install web3. So we need to go to our app, npm install web3. Then we will see that in the package.json we'll have the web3 library here. Oh yeah, we have it here. Web3 version 4.13. Then we need to import the Web3 library here in the React app. So to import the Web3 library, we just need to type import Web3 from Web3. I'm going to put this in the README as well. Import Web3. So that's the second step. After that, we need to initialize the Web3 object. To initialize the Web3 object, we need to type new Web3. So we are initializing this Web3 object from here. In this case, we are going to initialize the object with something that is called window.ethereum. This window.ethereum is basically the MetaMask or the wallet of the user has in the browser. So in this case, because I have my MetaMask here, we are initializing my Web3 object with my MetaMask with the network that I'm connected. In this case, if I'm connected to Sepolia, then I'm initializing this dApp with Sepolia. But then if I change to another network, we are initializing this dApp with another network. To do that more, like maybe graphically, I'm going to show you something else. Maybe put it here, initialize Web3. Are you familiar with use state? You know what is use state in React? Perfect. So I'm just going to create here a chain ID. I will just create maybe P network ID or chain ID. Okay, so what I'm going to do is just to show you how we are going to be connected to different chain IDs just by changing the MetaMask network button, update chain ID. Before we interact with the contract, so you understand that a little bit better. Sync function update chain ID. Okay, so we just initialized the web3 object by typing const web3 equal to new web3. So first thing import, second thing initialize the object, and then after you initialize web3, you can use web3.js just by typing web3.eth.get whatever that you want to do. So I'm going to show you here in the docs. You have all the different methods that we have available in web3.js here, web3.eth, and then you can see get accounts, get balance, get block number, get chain ID, etc. So for this one, I'm just going to get chain ID, and then I'm going to store that in this variable, and then we are going to show that in the front end, chain ID string. Okay, do you have any question with this? Maybe I'm going too fast or something with the first thing. Let me just recap again. First thing we did, import the web3 object. Second thing, initialize the web3 with window.ethereum. And then we are basically just using one method of web3 to get the chain ID that we are connected right now. And then the network that we are connected right now will be the network that we have in our MetaMask. So right now, if I connect my MetaMask to Ethereum mainnet, and if I click in update chain ID, we are getting a 1 because this is the chain ID of the Ethereum mainnet. And then if I change to, let's see, to maybe Polygon, and if I click in update chain ID, we get another chain ID because now we are connected to Polygon. So web3.js will allow you to interact with any EVM network, Polygon, Optimism, Arbitrum, Ethereum, etc. zk-Sync, Base as well. Celo is also a layer 2. So if we connect to Celo and then we click in update chain ID, it will be the same. In our case, we want to interact with Sepolia because it's a testnet. So I will just put Sepolia here, and then we will get the chain ID of Sepolia, which is this one. And look that right now what I'm doing is fetching data from the blockchain, and I'm not spending data for this. So every time that you fetch data from the blockchain, we are not really sending transactions. We don't need funds for this. But then when we try to set the message, we will need funds to set the message. Is this part clear first of the initializing the Web3 object with MetaMask?
Yeah.
Another way that normally you don't use this in an application is to initialize the object, initialize Web3 with an RPC. So here is with the injected provider. There are like two different ways. The injected provider will connect to MetaMask, but then the RPC is basically just hard coding like an endpoint of a node. So in this case, if I hard code something like, let me come here to, in chainlist.org, you can find a lot of different RPC endpoints. RPC endpoints are just like URLs to interact with the node in a specific chain. So if I come to Ethereum mainnet and I copy paste this endpoint of ETH llama RPC and I hard code this, that means that this get chain ID will always return 1 because it's connected to Ethereum. So I'm going to show you right now. I'm connected to Sepolia in my MetaMask, right? And this is the chain ID. But even if I click on update chain ID, it's returning 1, but I'm connected to Sepolia, right? Because it's already kind of hard-coded here that is connected to Ethereum. So those are the two different ways that you can connect to a network. Normally, I always like to explain and teach this one because when you are creating apps, this is the way that you use to also interact with MetaMask. With this second way of RPC, there is no way that you can ask the user to connect MetaMask. That's why we need to use the window.ethereum to ask the user to connect MetaMask. So I'm just going to delete this. Any questions so far? Yeah.
When you put there the RPC URL, does it fetch both like the provider and signer? Or only one?
No, only the provider. So that's the thing. You cannot really. Then if you want to send a transaction using the RPC, then you will need to input the wallet with a private key. Because you cannot ask the user in the browser to connect the wallet with the RPC endpoint. Yeah, only with the window.ethereum, with the injected provider. So it's only getting the provider, not the signer. Yeah, is that clear? Perfect. Any other questions? No? Clear so far? Or you are already lost? I mean, yeah, so far what we did, import web3 library. There's a lot of lines of code. Then in line 11, we initialize the web3 library. And then here we are using the web3 library, web3.eth.getChainID. But then if I get something else, like maybe get balance, and then this get balance will receive an address as a parameter to check the balance of that account. So if I input, let's say, my address, it will return the balance of my address. So let's just change this to fetch my balance. And then if I click here, yeah, it's fine. Then you can see that my balance is 2.9. In this case, it's this whole string, but it will be 2.988, etc. Do you know the difference between Ether and Way units? No? Okay, so then let me show you that too. Okay, you are learning a lot today. So Ethereum has different units, right? Like in the same way that we have like 1 cent or $1, we have the same in Ethereum. So 1 Ether is 10 to the power of 18 Way. Way is the lowest unit that we have in Ethereum. So that's why when I updated this is giving me the value in Way, not in ETH. Because the value in ETH will be 2.9, but the value in Way is 2988, blah blah, all these things with like it's 10 to the power of 18. So basically 2.9. If I put 2.9 ETH, this is 29 and then 18 zeros in the right. This is clear of the Way and Ether. There are a lot of more units, but these are the two main ones, Way and Ether. So that's just important to know. And let's say that I want to format this balance to have it like more beautiful, and I want to show it in ETH, right? Not this 29882. So we can also use the web3 library to format this. So instead of web3.eth, we can type web3.utils, and then there is a lot of different utilities that you see here. Let me show you in the docs where is that as well. That's here in utils. So web3.utils, here we have web3.eth, and there is even more, the web3.ens, etc. Web3.utils, and then we can say from Way, because we wanna format this balance that we have in Way to Ether units. So this will receive two parameters. The first one is the number, so in this case will be the balance, and then the second one is the unit that we want to convert these units to, and I will put it in Ether. And then we can put this formatted balance, and then we can update the front end with this, and then let's see if this works. Yeah, and then as you can see now we have 2.9 ETH is my balance. So this is basically the web3.js library in action. Here we are getting a balance, here we are formatting the balance, and you can even do more things. Now we are going to interact with the contract, but before we interact with the contract, I just want to ask you if you have questions with these lines of code with web3.js so far. Bit more soon. No? Is this clear? Yeah? Perfect. So now let's interact with the contract. So we are going to have three main functions. One will be to connect accounts, like to ask to the user, hey user, please connect an account. The other one is to get the message, and then the other one will be to set the message. These two will be to interact with the contract, get message, set message, and this is just to connect, to ask the user, hey user, connect an account. So let's first ask the user to connect the account. So to connect the account, we just need to type web3.eth.requestAccounts. And basically, if you just run this, it will already pop up MetaMask to ask the user to connect an account. And then this will return the connected accounts in an array. I'm going to show you this in the console to see what is connecting. So let's change this button. updation ID to connect accounts. I actually have all the buttons here. Set message. Okay, I think it's looking better now. Connect accounts. Okay, so far we have this. We are going to connect the accounts, we are going to get the message, and we are going to set the message. But for now, only connect the accounts. Let me just disconnect the account first. Okay, so I just disconnected the account. And then if I click in connect accounts, and remember that the connect accounts button is just calling this function, which is using web3.eth.request accounts, and it will return the connected accounts. So let me open the console. I click in connect accounts, MetaMask is popping up, and then it's asking me the accounts that I want to connect. In this case, I will just connect JKUAT. I click in next, confirm, and then we see the account in this array of accounts. So this is basically how we can ask the user, hey user, connect your account to the dApp, and then MetaMask is popping up asking the account that he wants to connect, and then the app will only have access to the address. We are not having any access to a private key or to play with the funds of the user. That's not happening at all. It's only to the address of the user. Any question with this request account so far? Okay, perfect. Now let's play with the contract. So the first thing that we want to do is to get the message. So let me just come back here to this README, initialize the web3 object. So accounts web3 window.ethereum. Connect accounts. Perfect. And then initialize the contract. So to interact with the smart contracts, we will always need something that is called an ABI, the application binary interface of the contract that we are going to interact with. So in this case is this contract. Yeah, so I came back to the contract that we deployed like a few minutes ago. I will click here in contract, and you can scroll down and you will see the contract ABI here. Or the other way to find the contract ABI is here in Remix. If you come to Remix and then you click in Solidity compiler, you will also see the ABI here. So you can copy the ABI from any of those two sources. In this case, I'm going to use the Block Explorer. So we have the ABI here. We need the ABI to be able to initialize the contract object with web3.js to interact with that contract. So let's click here. Okay, so I just copied this ABI. And then I will store that in this source, abi.mjs. I will create a variable here that is the ABI, and I'm just pasting the ABI that we saw in the Block Explorer. So is this object here, and then I need to export this export default ABI. Any question with this so far? I just copy paste the ABI from Block Explorer and then I just put it here. Perfect. And now we will need to use the ABI in the app. So we need to import the ABI. Import ABI from abi.mjs. And then we can initialize the contract here. So to initialize the contract, let me update the README here. We need to type new web3.eth.contract, and then we pass the ABI, and then we pass the address of the contract. I'm putting this in the README as well. So look that we are always using the web3 object to do everything. In this case, web3.eth.contract, and then this will receive the ABI that we just copy paste from the Block Explorer, and then the address that we also have in the Block Explorer, and then we are able to play with this contract instance here. So let me just do that in the app. Cons contract instance equal to new web3.eth.contract. Then this will receive, you will see that this is receiving here the ABI first, and then the contract address that I'm going to get from iterscan now address. So if I come back to iterscan, to Bro Explorer, iterscan, we see the contract address here. So I can just copy the address and paste the address here. And now we initialize the contract by using these two things, the ABI and the address. Any question with this initialization of the contract? Yeah.
There's no way to just use the address itself.
No, because then when you're trying to interact with the contract, it will not know what are the functions that the contract has. But then the ABI is telling the Web3 library, this contract has a get message function and this contract has a set message function. So you are able to interact with the contract with the ABI. We have a plugin in web3.js and it's called contracts plugin. And basically what you can do with this contract is initializing the contract only with the plugin, with the address, sorry. I think I have an example here. Oh yeah, it's here. So you can just type web3.contract.source and then you pass only the address, and then what happens is that this plugin is connected to iterscan under the hood and then is fetch the ABI. But then this is just like a easier way to initialize the contract only with the address without the ABI if you want to use this. And then to use this you will need to install this plugin npm install web3 plugin contracts. But yeah, then the normal way will be looking for the ABI and looking for the contract address. Any other questions with the contract initialization here? Okay, and now we can interact with this contract instance just by typing the contract instance dot methods, and then after these methods we need to put the method that we are going to interact with. In this case is get message, and then after the get message we need to specify that this is a call because we are not sending a transaction. So dot call, and this is basically how we can interact with the contract to get the latest message. Then this will return the message that we are going to store in this variable, and then we can render that in the front end. So let's create a use state here. Const message set message. No message. Okay, and then we are going to set this message here once we get the message. And we need to update the front end too. Yeah, to show the message here. Okay, so by default in the use state I have this no message that I wrote it in line 9, and then this set message will be updated when we click in get message. In this line 25 it will make the call to the contract instance.methods.getMessage.call. Remember that this is the name of the function that we are calling in the smart contract, and then here we are updating the front end. So if everything works well, this should update the contract. Remember that then we need to be connected to Sepolia, because if we are connected, let's say to Ethereum, what will happen is that this will try to call this smart contract in Ethereum mainnet, but this contract doesn't exist in Ethereum mainnet. So if I click in get message, it will return an error that it says parameter decoding error, return values are not valid because it's not returning anything. But then if I change to Sepolia, where we deploy the contract, and then I click in get message, we get, this is the second message from JKUAT account. So right now we are interacting with this smart contract that is live on the Sepolia testnet, and this was the latest message that we have. Do you have any question with this so far, with the calls, how we can fetch the data? we're going to do this again with a different contract after. So yeah, I think with repetition these things are easy to learn, and it's just really hard to just learn everything at once. But yeah, then now let's interact with the set message function, because now we are going to send a transaction to be able to update this message that we have. So to interact with that function, we also need to type contract instance dot methods dot set message, because in this case that's the function that we are interacting with. And if you remember, this set message will receive a parameter here that will be a string with the new message. So let's say new message from the dApp, and then instead of dot call we need to type dot send, because we are sending a transaction. Then this will just receive an object, so we need to put the parentheses, then the curly braces, and we need to specify which account is sending this transaction. So that's why I open this object here, and then I put from, and then we need to specify the account that is connected here in this function, connected accounts. So I will just return the connected accounts in the slot 0, and then I will use this function here to be able to have access to that account. And then we can specify that the person, the wallet that is sending the transaction, is this account that we just connected here. Is this part clear? The connected account that is sending the transaction? Perfect. So yeah, remember that there are only two ways to interact with the smart contracts. Reading functions is just contract instance dot methods dot, in this case, get message, which is the function that we are interacting with, the method, dot call is way easier because we don't need to initialize an account. But then to interact with the writing functions is contract instance dot method dot the function that we are interacting with. Also, if you receive any parameters, then dot send instead of dot call, and then we need to specify which account is sending this transaction. Okay, let's put this message here to look better. Message, and then this will return a transaction receipt, and then we can just, if you want, you can just console log the transaction receipt. The transaction receipt will be an object with all the information of the transaction. I'm going to show that in the console, and then we can put this to connect the button to interact with this function. So button, click, set message. Any questions so far with this second function? No? We're ready to test it? Perfect. So then if we click in set message, let me open the console. Account is not defined. So this is not getting this connect accounts from here. Why not? Why connect accounts? No, why it's not calling it? So let's use set state here as well. Cons account and set account. The only thing that we need is access to the address of the account that we just connected. State, no address, and then I'm going to create that here, address account, then account, okay, then this should work in this way. Now I just updated the state to show us when we connect the account. It's supposed to show the account that is connected here, but it's not connecting. I don't know if I did something wrong. set account, maybe to string. I don't know why it's not showing the account. Yeah, it's this one. Account equal to 0, and then we are just updating the front end here. Set account and account here. Yeah, okay, so let's see if this works. Oh, I don't know why it's not showing the... You guys can spot any error here? Yeah, I'm making an error connecting the accounts. I'm just trying to set the account here. Oh yeah, this is the error. Yeah. Okay, so when I click in connect accounts, it's just updating the front end with the account that I just connected. In this case will be this JKUAT. And if I disconnect, it will ask me to connect an account. I connect that one, confirm, then it's showing here. Then if we click in get message, we get this message. This is the second message from JKUAT. And then if I click in set message, now we are going to set the message with the new message that we sent. We just click in confirm, and the message that we just sent was the new message from the dApp. So this will be the new message. Okay, this is the transaction receipt that we get when the transaction is done. I would say the most important thing here is the transaction hash, in case that you want to verify in the block explorer that the transaction was done. Okay, so it's not done yet. Oh, I put the quotation marks. Yeah, and then you see that the transaction succeeded 32 seconds ago. We called the set message function in this smart contract. And then if we go to our smart contract, we deployed the contract 39 minutes ago. Then we set the first message 34 minutes ago, and now 42 seconds ago, we just call it from the dApp. And then if I click again in get message, we get the new message from the dApp. That was the new message that we just updated. And then we can just, you can also just put an input form, and then you can add a text, but in this case I'm just hard coding the message here. Hello JKUAT. And then if I click again in set message, now I'm going to change the message to hello JKUAT. We can wait until the transaction is executed here. We'll receive the transaction hash, and then we can get the new message. Oh, okay, yeah, now it's done. And then we just get the new message, hello JKUAT, and that's how we can create a dApp to interact with our smart contract to set the message. So I would like to go back to all this code, but I don't know if you have any specific questions before I kind of do a recap of the code. So yeah, open to any questions so far. Clear? Yeah?
How is managing the accounts?
The accounts. Okay. So what we did first is that we need the account only to specify in this line 32 which account is sending the transaction, right? So that's why we need to create this function connect accounts. The connect accounts in the line 20 is asking the user to connect the account, right? That's why MetaMask will pop up and we'll ask the user, hey user, connect the accounts, and then you will choose one or two or whatever accounts that you want. And then this will be stored in this array of connected accounts. And then I just store this in this new account because I'm just getting the first account that the user connected. Remember that this is an array of accounts. In case that you connected a lot, I'm just getting the first account. And then I'm updating that in the front end with this set account in the line 22. So yeah, here we just ask the user connect the accounts. Here we are just getting the first account connected. And here we are just rendering the front end. Then what I did is that I used this state of the account. in this line 32 to specify which account was sending the transaction. I can also just hard code here my address and it will also work, but yeah, that's not like a realistic way of doing it. But we need to specify when you send a transaction which account is sending the transaction. That's why we did these connect accounts here. And that's the only difference between writing functions and reading functions in a smart contracts, that for the reading functions you don't need any account, so it's really easy to interact with. We just need to initialize the contract. But then for the reading functions, we always need to specify which account is sending the transaction. Does that answer your question with this? Connect accounts? Perfect. Any other questions? I'm open to go over everything, to explain in a different way or something. Everything clear? Okay, so then let me just kind of walk you through everything that I did. The first thing was to import the Web3 and the ABI. Web3 object and ABI. Remember that we will use the ABI to initialize the contract. So once we imported the Web3, we just, let me put in steps. First step, import the Web3 object. Second step, we need to initialize the Web3 object. In this case, with the injected provider, that this is the network that you are connected to MetaMask in the browser. Then the third thing that I did was to initialize the contract. To initialize the contract, we will need the ABI. Remember that you can get the ABI from the Block Explorer, and you will also need to specify the contract address that you want to interact with. So that's why we have this new web3.eth.contract. We pass the ABI and we pass the address. And then once the contract is initialized, you can interact with reading functions in the smart contract just by using the contract instance .methods .getMessage .call, and then this will return the message that we already have in the contract. And then the second thing that we did was to interact with writing functions. Interact with writing functions in the smart contract. But then for that interaction with the writing functions, remember that we need to initialize an account to ask the user, hey user, which account do you want to use to interact with this contract? So that's why we created this function of connect accounts that will request the user to connect the account in this line 22. Request user to connect an account. Then we are just getting the first connected account and just updating the front end. So that's what we did here. And then to interact with the writing functions is the same contract instance .methods the method that we are interacting with, in this case send message, we send the message as a parameter, and .send. This .send will have this object that will specify which account is sending the transaction, and in this case was the account that the user connected in this previous function. And we are just like printing the transaction receipt just to show it there in the console, but that's not necessary. And yeah, that's basically how we have a contract. We deploy the contract, then we create a dApp to interact with this contract that we just deployed. I will also publish this. There is the recording and everything. We'll also publish the code on Twitter, so you're able to follow this. But do you guys have any question from the smart contract, from the dApp, from web3.js or something so far? Because then what I was planning, there are two things that we can do now, is to use the same smart contract, but we can add any other functionalities to this, or just have a different smart contract like from scratch. So what I want to do is just to write a new contract, deploy this contract, and then create a dApp to interact with this new contract again. And then you will get the idea again of initializing the contract, initializing web3.js, etc. What do you guys want? Should we add more functionalities to this contract? Should we eat? Should we have lunch, or what do you want? Is Gideon here? Gideon is not here. I know Gideon is the leader here. Where is our leader? Leader is not here. Yeah, but yeah, I'm open to anything. What do you want?
We can add more functionality.
We can add more functionalities. Okay, I like this guy. I like that initiative. Okay, so just for the ones that were not present in when we wrote this smart contract, we just wrote a simple smart contract that can do two things. It only has two functions. One, to set a message. So this set message is updating the message state variable that we have in line 8. And then this function of get message will just return the current message that we have. So that's the only thing that this smart contract is doing. So what would you like to add to this contract? I hope you don't ask for something really hard. What would you like to add? I already have like some ideas. Maybe for example we can have a, do you know what is a mapping? A mapping, yeah, it's like a, how is that called? A key value pair. Yeah. So we can have a mapping that can say which message or which address send the message. So for example, if I send a message, I'm Santiago, this will be connected to my address. And then if someone else send a message, I'm Gideon, that will be connected to a different address. Or what we can, or what else? I don't know. We can have also a owner of this contract, and only the owner can set messages instead of anyone. Because right now, if you guys come to this contract, you can set messages now. But then if I created like a owner, and this owner can only update the message, then only me will be able to update this message. Or I don't know. Tell me about any ideas that you get to make this smart contract a little bit more fancy. Yeah.
I have a question.
Yeah.
So what are some of the applications of the smart contracts in blockchain?
I think the main applications right now that we have is DeFi. So DeFi is decentralized finance, and it allows you to have different, let's say, money liquidity pools inside the blockchain. But then something that you can do. Okay, this is a little bit more advanced, but let me tell you something. Maybe in Paint will be easier. This is always the best use case that I find in blockchain about the Uniswap, for example. This looks so ugly. So you know that if you have, let's say you have this looks so ugly. You have USD and you want to change that for Kenyan shillings, right? Jesus Christ. This is not... Okay, now I'm struggling with Paint. Okay. And then if you want to change this, let's say that you have one USD and you want to change for that value in Kenyan shillings, right? So what happens is that you will need someone that has the Kenyan shillings to be able to receive this dollar, so you can do the swap, right? In real life, that happens in real life. When you want to exchange money, or you can go to an exchange or any Western Union, whatever, and because they have the liquidity, they will give you the Kenyan shillings. Or if someone else comes with $1 million, then they can give that money in Kenyan shillings, right? But then a really good use case, one of my favorites that we have is Uniswap. So Uniswap allows you to have something that is called liquidity pools. So this is, let's say, a pool. And then we have a pool of a lot of USD here, and then we have a lot of Kenyan shillings here. And then what happens is that you, as a user, can come to Uniswap and say, hey, I have $100 that I want to change for Kenyan shillings. So what happens is that now you don't need to interact with Western Union, you interact with Uniswap. You put these 100 shillings in this liquidity pool, and then you will get the Kenyan shillings from this liquidity pool, right? I don't know how much will be that in Kenyan shillings, but then you will get that here. But then the most important part is that this liquidity pool is made by people that put their money there. So let's say that you have a lot of $1 million or Kenyan shillings, so you can put your Kenyan shillings here in this pool. And then when people do these swaps, when people are doing these swaps from USD to Kenyan shillings, they are paying a little fee to this liquidity pool. and that fee is shared among all the people that put their money in those liquidity pools. So if I have USD and Kenyan shillings, I put here my money, and every time that you come here to do this swap, let's say I'm getting 0.1 cents or something like that. And then if that's happening the whole day, a lot of people doing swaps, I'm getting 1 cent, 1 cent, 1 cent, 1 cent, 1 cent, 1 cent. And that's why this is called decentralized finance, because no one is the owner of this. There is no Western Union as a main we can call it entity managing everything. And this is just smart contracts that are managing this. Everything is written. That's another level of smart contracts, because then you will have tokens, you will have the liquidity pools, you will have a lot of things. But all these things is written in smart contracts. And as you can see, you can go and verify that the code of the smart contract is doing that. The thing is that you will need to know more like advanced solidity to be able to understand these logics. But this is a really good use case of smart contracts. These liquidity pools where people just put their money and people can withdraw their money, people can make swaps, and every time they make a swap, they are getting a little cents. So instead of me going to a Western Union and changing my 100 USD for Kenyan shillings and paying Western Union $10, I can come here, I will pay, let's say, $1 of fees, and I know that that dollar is going to people. It's not going to Western Union. And yeah, that's a really good use case of Uniswap liquidity pools. Did you get it? Do you have any question with that? It was clear? Yeah, I don't know. I never explained this in this way. But yeah, I hope that you got the idea of liquidity pools. Yeah. Any other questions? Yeah, but I think DeFi is the best. Yeah.
Is there a way that you can, for example, you have a smart contract?
Yeah.
And you deploy it. Is there a way you can maybe create functions or something like that, but using the not necessarily
Not really. No, to create a smart contract, you will need to use Solidity. But once a smart contract is there, then with the JavaScript you can interact with that. You can create a dApp that can interact with an existing smart contract. Like for example, these liquidity pools already exist, and you can create a liquidity pool of your own token. Let's say we can create a, what is your name? Eugene. Eugene. Perfect. So let's say that instead of this, we have you create a token, and you want to create a token, right? So you can create your own liquidity pool. Let's say this is Santiago tokens, and then your name is with J, or oh yeah, that's fine. We'll just put the G tokens, and then this is Santiago tokens, right? And then we can create our own liquidity pools just by calling the Uniswap smart contracts, because with JavaScript you can call the smart contracts, and then by calling the smart contracts you are already interacting with them, and then by calling the Uniswap liquidity pools you can create these tokens without knowing Solidity. But then that will need Uniswap docs. That will require a little bit of learning the Uniswap documentation and understand how can I create a liquidity pool when I have all these different, when I have like these two tokens or something. But yeah, Uniswap has like a lot of things, but that's something that you can do with JavaScript. Without knowing Solidity, you can create these liquidity pools of Santiago tokens and Eugene tokens without writing that from scratch, because this logic is already in Uniswap, so you can leverage the Uniswap protocol to create the liquidity pools. And then people can come, and if they have Santiago tokens and Eugene tokens, they can put money there, and every time that people are exchanging these two tokens, the liquidity providers, that's called liquidity providers, the people that put the money here, will get paid the 0.1% of the swap or something like that. I don't remember the number here, but normally you pay 0.01% of the swap that you are making. So if you are just exchanging $100, you are paying like tiny pennies for that. But yeah, with JavaScript you will be able to create the dApps without knowing Solidity. That's something that you can do. Any other questions? I'm open to any questions, or just to then to add some functionality here, I guess. So which functionality would you like to add to this contract? what do you think that we can do?
Keep the ownership one.
Sorry?
Access control one.
Access control. Okay, perfect. Okay, that's a good one. So access control is basically, I don't want that anyone can interact with this contract, right? And then we want to add like a access control that's only some specific people can interact with the contract. And which access control would you like to have? Only an owner or only some addresses? Or what do you think?
Only someone.
Some addresses. Okay, and we need to think about some logic here. Okay, so remember we have this contract that only set message and get message, but now we want to add the functionality that only certain addresses can interact with this function, with the set message. The get message doesn't really matter because anyone can, I think anyone can get the message, but not anyone can be able to change the message, right? So something that we can do, like in a really bad way, I will say that we can just add a require, and then we can say this is a how is that called? A variable. I forgot the name of that. A variable. How is that called? This message.sender. I forgot the name of that. A variable from Solidity. This message.sender is basically taking the address that is sending the transaction, that is interacting with the contract. So this is just fetching the address, and we can just say message.sender should be equal to JKUAT. So here we just added an access control that only allows. What is the? Oh yeah, this will not be an address. Oh yeah, address. Needs to be something like this. We're going to do this in a better way. Yeah. So what we are doing here is that only the message.sender, remember that message.sender is the wallet that is sending the transaction, must be equal to this address. So I'm just hard coding here that only my address can call this function, because if this is false, if this statement is false, then you will get this error, it will not work, and then you will get this message, you are not JKUAT address. So this is like a really simple way how we can do the access control. But something that I have in mind, but I don't know if that will be too overwhelming, is actually creating maybe a mapping with addresses that we can set as true. We can do that, but I don't know if a lot of people can get lost with that, but we can try. So who is not familiar with mappings, with key value pairs? Everyone is familiar with that? Okay, so I'm going to create a mapping where I'm going to set that an address will be true, and the addresses that are true can interact with this set message. And by default, any address will be false, so no one can interact with this, except if the address is true, right? So this mapping will be address to bool, and let's say has access. So before we do that, we are going to check that require. The way that we can access to this mapping is by putting the name. So has access, access, and then we open this. I forgot the name of these brackets in English, right? Yeah, we put these brackets. I'm a Spanish speaker, so sometimes I don't know I miss some words. Yeah, the square brackets. Has access, and then we send the address. There will be message.sender, and then this will return true or false, right? And then if this is true, this will allow us to set this message. But then we can also return here, you are not allowed to interact with the contract, or to set the message, to change the message. Okay, I want to know if this is clear. I just added 2 lines of code. The line number 9 that is creating a mapping that will have addresses and booleans, and then the line 25th that is accessing to that mapping to get the answer if the mapping is true or false, if the address is true or false. Do you have any questions with this so far?
This like loop over the mapping. If the mapping as
So
well?
that's the beauty. Okay, that's a good question. In Solidity there are also arrays, but then when you have an array, the only way that you can access to that is looping through the array. That's why arrays are not really used in Solidity. And then accessing mappings.
You can't directly access an array in Solidity. You have to loop through it. I don't know what you mean.
Yeah, but the issue is that in Solidity, arrays are not really every interaction, every loop, or every little thing that you do will cost gas. And then when you do something in an array, is not as efficient and using mappings, because the mapping will already access that key and it will return the value right away. But then with the array, you will need to access to the array, or you will need to iterate to the array. You can access these different indexes in the array, yes, but that's less gas efficient. So yeah, I don't really see a lot of arrays, to be honest, in Solidity, and mappings are the kings of Solidity. Any other questions? No? Yeah, basically we just added this require here with this checking of the mapping, but then we also need to add addresses here, right? So we need to add more functions. Okay, let's put a function that says whitelist an address, new address, external. Okay, maybe, and then we can do that. Only my JKUAT account can call this whitelisted an address. So this whitelist an address will set the address to true. So this address will be able to set a new message. So here I'm just, to make it easier, I'm going to hardcode that message.sender has to be equal to my JKUAT account, which is this one that I copied from here. You are not JKUAT. And then after it verifies that I am the JKUAT account, it can whitelist a new account by accessing this has accessed, then putting the new address equal to true, because by default it will be false, but then we are giving access to this new address in our mapping, and then we can create another function just to check if an address is whitelisted or not. Is whitelisted address. So this will be a reading function, external view returns, and then this will return true or false if an address is whitelisted or not. So we just type bool, and we just need to access to the mapping. So has access, we open the square brackets, we send this address, and this will return true or false. Okay, I'm open to go through this again if someone has any questions. We added two new functions. One function that will allow only my account to whitelist addresses. Then this function will just show us if an address is whitelisted or not. And then in the set message, we added this line 25 to only allow whitelisted addresses to access and update the message. Is that clear? Yeah, okay, so now let's try this in Remix. So we can come to deploy and run transactions. We come to Remix virtual machine, which is just like this testnet environment. And then, then we are, okay, the thing here is that here I'm putting my JKUAT account, but in Remix we are going to interact with these accounts. So I'm just going to change this account. Okay, so I just hardcoded that the account number 1 can whitelist addresses. So this is this account. And then maybe it will make sense that in the constructor we also whitelist this account. So we are going to give access to the deployer of the contract to be able to also set messages. So we need to type this has access message.sender equal to true. So the wallet that deployed the contract will have access right away since the constructor. So this account number 1 will have access to set messages. So if we click in deploy and then we scroll down here, we have get message. The get message is first message that we have in the constructor. And then if I try to set a second message here, second message, and then if I click here, it works because the account that deployed the contract has access, is whitelisted, right? But then if I change to the last account, this one that ends in 148, and then if I try to send a third message, and then if I click in set message, we are getting an error that says you are not allowed to change the message. So basically this is stopping the execution in this line 26, because it's checking that the account that is sending the transaction is false because it's not set to true, and then that's why it's returning this, you're not allowed to change the message. But then if I go back to account number 1, which is this one, but I will copy this address because now I want to whitelist the last address. So if I come back to account number 1, and then I come to whitelist an address, and I just paste the account 148, that was the last account. I just click here, okay, it's true. And then if I come back to the last account and I copy this and I come to is whitelisted, is returning true. So now I can set the third message. Yeah, now it works. And then if I click in get message, we were able to update the third message. And if I just check any random account, if it's whitelisted, it will be by default will be false. For example, this one, I just copy this, and then I just click in is whitelisted, it will return a false, because the only accounts that are whitelisted to true are the first account, this one, and the last account. So only these two accounts can change the message right now. And then if I can whitelist all these accounts as well, and then they will be able to set the message as well. Is that clear? Now it's getting a little bit more complex, I think. But yeah, I'm happy to repeat anything. You guys have any question? Are you able to understand this whitelisting logic? Yeah? Please don't be shy. I'm really happy to just start again if something is not clear. No? Is that clear? Okay. Gideon, do we have food? Yeah. Do we have food? Yeah. Is ready now? Oh, okay. Because then I think before we start with something else from scratch, it will just be better to wait kind of for the food. I'm hungry as well. Yeah, do you guys have any question with this smart contract? Now, if we want to interact with this new contract, with this new logic, then we will need to deploy a contract again. And then that will have a new ABI. It will also have a new contract address. And then the only thing that we will need to change here will be the ABI and the address. These two methods will be the same, set message and get message. But then we can also interact with these other two functions to whitelist address and to check if the address is whitelisted. But yeah, every time that you update something in the smart contract, it needs to be deployed again, because now you change the logic and now the contract will be different to what we wrote here. So yeah, I think if you don't have any questions, you can just like take a break, wait for lunch, I think. I will be here open to questions if you have any questions. Yeah, okay, so now, okay, thank you. Yeah, so this is after 1 hour and a half is the token part. 0.8.0. First, I'm going to show you what is a ERC20 token in real life, but we are not going to implement the whole thing because that will be too overwhelming. But I'm going to show you the functionalities of a ERC20 contract, which is here. Yeah, so basically the ERC20 token has all these functions. a constructor that will receive a name and a symbol as a parameter, a name, a symbol, decimals, total supply, balance of, transfer, all these things. But for the case of the token that we are going to build now, I'm going to have only some of them. Let's call it JKUAT token. Okay, remember that first we have the state variables. So for the state variables of a token, normally a token has a name, that would be like a string. Also a symbol is also a string. A total supply will be a uint256. And then a mapping of balances, which will be addresses with uints. But then for this tutorial, we are going to have maybe only the name of our contract. What else? Maybe total supply. And the most important, the balances. So the balances is a mapping of addresses and uint256. And this will update the balance of every address that by default will be 0. It will be always 0, and then we need to update that. Do you guys have any question with these 3 state variables so far? No? Okay. I will go slow. So we have a name, a total supply, and balances. And this is how we start the contract. So in the constructor, I'm just going to initialize a name, so our token will have a name, right? So we need to put this variable here to update it, name equal to, and then we can send a string as a parameter to update the new name. New name. This is literally how a ERC20 token is. When you see the constructor of the ERC20 contract, you always receive a name and a symbol, but in this case I just have the name. That will be easier. And then I'm going to implement some functions that are the most important ones, the main one of a ERC20 contract. One will be mint, because by default, if we don't have tokens, it will be 0. Then burn, if we want to kind of burn tokens. Then we can implement maybe transfer, if we want to transfer tokens from one address to another address. And then another one can be balance of, if we want to get the balance of an account. Okay, min, burn, transfer, balance of. Yeah, this can be the main ones, or maybe total supply to get the total supply as well. Total supply. Okay, so these are the functions that our ERC20 contract will have. Mint will mint tokens. Simple, right? Because by default we have 0 tokens. The burn will just burn the tokens. Transfer, update balance from account A to B. The balance of will return the balance of a given account, and the total supply return tokens minted so far. That's like the total supply function. So these are the functions that we will have. Do you guys have any questions with the functions that we are going to implement here? I haven't implemented this before, so I'm doing this for the first time, but hopefully it will work. So any questions with these functions? Yeah?
Why would someone want to burn the token?
That's a good question. Why someone wants to burn tokens? That happens a lot in the real world of ERC20s. That happens a lot when you wanna, for example, change tokens from one chain to the other one. So that's how bridges work. Let's say we have Ethereum and we have Arbitrum, and if you have 100 USDC in Ethereum, you don't have that in Arbitrum. You only have it in Ethereum. But then if you want to bridge that to here, what happens is that they will burn 100 tokens here and they will mint 100 tokens here, or the opposite, the vice versa, if you want to do that. But other ways, okay, maybe you create a token for a game, and then you need to redeem some tokens in order to pay for something. Maybe the redeem is burning tokens. The burn is just kind of making tokens to disappear. To kind of, no one owns those tokens anymore, so they cannot be spendable. They disappear literally. Normally, what people do to burn is sending the tokens to the address 0. So when you send tokens to the address 0, is like you burn the tokens, because the address 0 like doesn't exist. That's something that is just like that, in that way. But yeah, normally why you want to burn money? That's not really to also to reduce how is that called, inflation. But yeah, the burn is always there, and I wanted to implement it, but that depends on the use case. Yeah. Any other questions? So far we only have comments. We haven't done any code yet, but this is important that you understand what we are going to do with these comments. Yeah? Okay, so I think we can start with the total supply. Actually with mint. Mint will be the most important one. So function mint external. So what do you guys think that the function mint will do? Any ideas? Or I can choose someone randomly. No one? No volunteers? Okay, you. What do you think that the function mint will do? Will what? I cannot hear you. And what? Oh, okay, someone else. No one, no idea what the main function can do? You got an idea? Create the token. Right, we are minting tokens, so we are creating tokens, that's true. But then when we create tokens, in this case, when you create a token, you need to do two things. Update the balance of the person or the wallet, let's say the address, not person, who is receiving the tokens or minting the tokens. And then you also need to update the total supply, because if we create more tokens, we need to update the variable total supply, because now we have more supply, right? So when we update tokens, when we mint tokens, that means that all the balances of all the addresses are 0. But then when we mint the token, we are updating the balance of an address. So to update this, we need to check this mapping, and the mapping is called balances. And what will happen with this line 18 is that we are updating the balance of message.sender. Remember that message.sender is the address that is sending the transaction, so the address that is calling this mint function. And then we are going to mint, let's say, 10 tokens. So right now, doing this, I'm saying the balance of his account is 10, and I'm minting 10 tokens, just like this, right? But maybe what we can do is put plus equal, so we just don't reset that to 10 every time, and we just put the sum of the current balance plus 10. Do you guys understand this line 18? We are literally minting 10 tokens. By default, the balances of everyone is 0, but then when the message.sender calls this mint function, now this will sum 10. And that's how your C20 tokens are minted. Literally just updating this state variable from 0 to 10. And now I mint 10 tokens. Do you guys understand this line? And because now we updated the balance of an address, we also need to update the total supply. Because the total supply is this number, so we just need to type total supply plus equal 10. Because we are minting 10 tokens. Let's say mint 10 tokens. Is this one clear as well? That's how we mint tokens. Just by doing this. In real life, this is how a token is minted. The only difference is that maybe this will have some require, and you cannot just go there and mint 100 USDC. Maybe they will have some criteria, but this is how tokens are minted. Just updating the balance mapping and updating the total supply, now tokens are minted. Just like that. Question with the first function? No? Okay, please ask questions if you are lost. I'm really happy to go back through everything. The second thing that I'm going to implement will be a total supply function to actually get the current total supply that we got. But let me just put this organized. Writing functions. And then reading functions. Okay, so first let's implement the total supply one. So this is a reading function, so we will have view returns. So total supply, external view returns. Remember that the external allows anyone like outside of the smart contract to call this function. If it's private or internal, no one will be able to interact with this function. And then the view returns is because this is a reading function that will return a UN256. That will be the total supply. Okay, why is the error? Oh yeah, the error is that this is the same name as the state variable here. So I will just call it like this. Total supply and total supply. Okay, any question with this total supply function? So now we can test this. Now we can try to mint tokens. And we have two functions now, mint and total supply. And we need to choose a name for the contract. So when we deploy, it will ask for a name here. Let's call it my token. I deploy. And then when I come here, we only have mint 10 tokens and total supply. If I check in total supply, we have 0. And then if I click in mint 10 tokens and total supply, now we got 10. We just minted 10 tokens. Is this clear too? Okay, I want to go really slow so everyone is able to understand.
Back to the function.
Which one?
After the total supply, external view return.
Yeah. This one. There was an error that I have. Yeah, maybe you have it, the error that the total supply function was called the same as the state variable total supply. That's why in the total supply state variable I put this underscore, so it doesn't have the same name. Anyway, I don't have any issues waiting until you got it too, so it's fine. Let me know if you are able to find the issue. I can go too. Got it? Perfect. Yeah, so the total supply function, the only thing that it's doing is basically returning this underscore total supply. And the underscore total supply variable is the one that we are updating every time that we mint tokens. Now, what we can do is that we can implement this balance of to send an address and ask, like, what is the balance of this address? So with these three functions, you will already understand, like, wow, so that's how tokens works. So function balance of, this will receive an address as a parameter. The address that we want to check if they have any balance. Then external view returns UN256. Oh, put the charger. Because this is returning a UN256 that will be the balance of that address. What's this? Yeah. So this balance of will return the balances. Remember that these balances is the mapping that we have here in line 9. So we are going to send, like, tell me the balance of this given address that I'm asking you for, and that will return the balance. You have a question? An error? Okay, that's perfect. Let me go and help you. I'm really happy to help. If you're not able to follow, that's fine. Maybe it's a syntax error or something. Perfect. Any other questions? Everything fine so far?
What's the difference between
Minting
minting and
and burning.
mining?
Oh, mining. In the ERC20 tokens, that's only called minting. But then mining is more about Bitcoin miners when you have a validator and then you are getting the rewards. It's a different concept, but for ERC20 tokens, it can be the same. I can call it mining or minting. It's the same. But yeah, it's just about what you are talking about, like the context. In Bitcoin, it's called mining. In tokens, it's called minting. Any other questions so far? Okay, I see you guys like the ERC20 tokens. This is the first time I'm doing this, so I will keep doing this ERC20 token contract. That's interesting. So we also implemented this balance of. This balance of will receive an address as a parameter, and then we are going to check what is the balance of that given address with this mapping. This is kind of checking the mapping state variable that we have in line number 9. Is this clear so far? Yeah. So now if I deploy the contract again here, now we have minted tokens, total supply, and balance of. Balance of will receive an address, so I will send this address. I will copy the address. I will check my balance, and my balance is 0, right? Then if I mint 10 tokens, and I check my balance again, now my balance is 10. And also the total supply is 10. So I have all the total supply is in my wallet. And then if I change the account to this one, the last one, and I copy the account, and I say, what is the balance of this one? It will say 0. And then if I click one time, it always moves like that, so annoying. And then I click again, so I'm minting 20 tokens. And again, 30 tokens. And then if I check the balance of this one, now the balance is 30. And then the total supply is 40. Is that clear? Not clear? Okay, that's fine. If it's not clear, let me go back to the minting function. So all the magic is happening in these mint 10 tokens. The thing that is happening in line 19 is that we are accessing, do you know what is a mapping? Are you sure? I don't see you like, So a mapping is this. Okay, now that's fine. Don't be shy with me. A mapping is basically this. A mapping will be, let's say this is an address. Let's say that these are different addresses, right? This is not the same address. Okay, so we have 4 addresses here. And then the mapping, what the mapping will do is store an address with a uint256. By default, the value of all the mapping, like all the addresses, is 0. Because we have address is kind of connected, is linked to a uint256. So this address is 0, this address is 0, this address is 0, etc. And all the addresses that you want to check will be 0. But then, when we are minting, we are saying now the balance of this address is 10. So this is just changing, updating the mapping of this address. And that's basically what's happening with the minting process. We are updating this, and then we also have the other one that is the total supply. This is like the mapping, balances, and this is the total supply. So every time that we minted, by default the total supply is 0. But then when we mint, now the total supply is 10. When we mint again, now the total supply will be 20. and then the total supply will be 30, and so on, because we are minting 10 by 10. That's what I'm doing here. And then when we mint more, then this one will be half 10, or maybe this one 20 or 30, depending on what's happening. But this is the mapping. Understanding mappings is the key to understand ERC20 contracts, because that's just basically a mapping of balances, of addresses, and U into 56. Is that clear? Any other questions with this? I'm happy to explain even more different ways or something. No? So everyone is understanding so far? Yeah? Okay, I'm happy. Yeah, so that's the trick of the minting function. The minting function will do that. We'll take this, and then we'll give the plus 10, plus 10, plus 10, plus 10, and then the burn function will do the opposite. We'll actually reduce this minus 10, minus 10, and then here will be the same. If you have 30 and then you burn 10, now you will have 20, or you will have 10, or then you will have 0. And then after 0, it will throw an error, because you cannot burn if you don't have tokens. So yeah, that's the trick of the minting functions in 2 lines. Updating the mapping and updating the total supply. Okay, that's great. And then these 2 functions are just reading functions. One is to check the total supply, and then the other one is to check the balance of a given address, as we did here. Are these 2 functions clear too? Perfect. Okay, so now we have this. Now we can do the burn. So if we mint by 10, we can also burn by 10 tokens to have it just to make it easier. And then we just need to update the balance of the address, of the message.sender. Does anyone has any question with what is a message.sender so far? Or you understand that concept? So perfect. So normally when we make a call to a function, we are calling from an account, right? We always need to call from an account. Normally I'm always using this first account. Or if I change to this one, then I'm calling from this account. And then if I call mint 10 tokens, the message.sender will be this one. Or if I change to this one, the message.sender will be this one. So the message.sender is the address that is triggering that function, that is calling the smart contract. So that's why if I call mint 10 tokens from this account will get 10 tokens. Or if I call mint tokens from this account, which is the last one, then this account is the one that will mint 10 tokens. So message.sender is the address that is sending the transaction, that is calling the smart contract. Because here, another thing that we can do here is just to, let's say, put this address. But then what we'll do is that every time that we mint 10 tokens, we are just minting 10 tokens to this address, not to the address that is calling the contract. And it's just easier if I'm an address and I'm called the contract, like you give the tokens to me, not that you give the tokens to this address. You know what I mean with that, with the message.sender now? Perfect. Message.sender is just the address that is calling that function. That's like I forgot the name of that. How is that called, Gideon? Default variable from Solidity? That has a specific name. Global variable. Yeah, that's a global variable. Solidity has global variables, and that's one of them, message.sender. Okay, so now to burn 10 tokens, we need to do the same. We need to update the balance of the message.sender. So what we can do is balances message.sender minus equal to 10. Anyone has any question with what is this minus equal or plus equal? Don't feel shy. No? You know what is that minus equal or plus equal? Okay, perfect. Because yeah, you're computer science students, but I was not, and I struggle a lot with understanding what is that plus equal. So you know that better than me. And then we also need to update the total supply, minus equal 10. Now let's see, I want to see something because I never done this. I want to see if an address has 0, if this will go to minus 10, or this will return an error. So I want to try that. I haven't done that yet. So let's do it for the first time, because then we don't want to have a balance of minus 10. So then we will need to add a require that says that it cannot go lower 0, but then let's try. So let's just deploy again the token. Now we have a new function, burn 10 tokens. So if I check my balance of this, let's just check the first account, this one, C4. Then if I check my own balance of this C4 address, is 0. And then if I try to burn 10 tokens, oh, okay, I think it's getting an error. Perfect. It says, yeah, it's returning an error because I already have 0 tokens, and in Solidity, negative numbers they don't exist. So that's why we cannot have a -10. But then if I mint 10 tokens, then if I click in balance off, now I have 10. And then if I burn the tokens, now it works. Yeah, perfect. So we don't need to add that require, because we don't have negative numbers in Solidity. Is this burn 10 tokens function clear as well? It's the same as the mint, but with the plus, with the minus. But it's the same. Perfect. Okay, now we can do the transfer function. So this transfer function will actually receive two things. The first one is the address that I want to send the tokens, and maybe by default as well, let's just say transfer 10 tokens. Let's just hardcode everything to 10 tokens to make it easier. So does anyone has any idea, this is a hard question, of what this transfer 10 tokens function should do in comments? Can you tell me what we should implement inside? No ideas? Gideon, do you know? Sorry? Some specific what? Okay, that's true, yeah. So we need to update the balance of a specific address. But in this case will be of two addresses. The one that is sending and the one that is receiving. So we need to update the balances twice. So let's say update the balance of the sender. So in this case, the sender is the person that is sending the token. So it will be the message.sender minus equal to 10, because I'm sending 10 tokens, so I will have minus 10 tokens, right? And then update balance of the receiver. What do you guys think that will happen here in this update balance of the receiver? Perfect. So now we need to increase the balance of this receiver plus equal 10. And that's basically the implementation of a transfer function. We remove 10 tokens in the balance mapping of the message.sender, and then we add 10 tokens in the balance mapping of the receiver. Is this clear? I think, yeah, if I get a workshop like that when I was learning, that will open my eyes to learn about ERC20 tokens in a really good way. I hope you are learning today too with this. Yeah, I think that's basically everything of a token. They have other functions that are allowance, approve, transfer from. We are not going to implement that, but what they do is here only me can transfer tokens to someone, right? But the transfer from function is allowing someone else to transfer tokens on my behalf. So that's why the normal ERC20 token standard has transfer from function, which will say, let's say that I give permission to Gideon to transfer my tokens. So my balance is 100 tokens. But I say, okay, Gideon, I give you an allowance. I'm the owner and Gideon is the spender, that you can spend 100 tokens of my balance. So then he will call the transfer from function and he will say, from Santiago to someone else, transfer 100 tokens. And that's the other transfer from function that they have, and then increase allowance and decrease allowance. That's just giving the permission of Gideon to spend 100 tokens or 200 or to decrease the allowance. And yeah, and that's how the ERC20 contract works. works, but I think the trick of everything is in this mapping, in the mapping of line number 9, where everything is stored, all the balances of the token. So if we run this, and then let's say token deploy, now this is basically a token with all the functionalities. It's allowing you to mint tokens, to burn tokens, to transfer the tokens. We can consult the balance of any addresses and also check the total supply. Maybe something else that we are missing here in the reading functions is a function that can return the name of the token. Let's call it name. We're just changing the name to underscore here. Yeah. Oh, here too. Yeah, and then if we just deploy this again, now we will have a new function. Oh, didn't work. Okay, we are getting an error. Oh yeah, we need to say string memory. Then we deploy, and now we have the name. The name of my token is token, that I just put it here when I deploy the contract. Total supply is 0. Total supply is 0. The balance of that we can transfer. Something else that you can do, for example, is like, okay, when I have the constructor, I want to mint 10 tokens to any other address. So you can say, let's say mint 10 tokens. I don't know if this one should work. Oh yeah, so I think, okay, you cannot call functions. Interesting. You cannot call functions in the constructor. Okay, new thing that I learned today. But then if you want to mint 10 tokens here, then you can also do the same. And then I'm basically just minting 10 tokens since the beginning in the constructor. But yeah, just to make it easier, let's just use this mint 10 tokens function. And before we start with React, to make like a simple integration with this contract, do you have any other question only for the contract, to go through the contract again? Any specific questions? Okay, I think it's pretty clear. We have these 3 state variables: name, total supply, and balances. Every time we are minting, burning, or transferring, we are just updating the mapping everywhere and also reducing or increasing the total supply. And yeah, three reading functions: the total supply, the balance of, and the name. And then 3 writing functions: mint 10 tokens, burn 10 tokens, and transfer 10 tokens. So now let's have fun with React. I will try to be slow in this one too. I think we can take maybe 30 minutes more if you have time. Tokens, and then let's have this React app. I want a React app that can interact with these 6 functions: 1 to mint, 1 to burn, 1 to transfer, and then 1 for getting the total supply, balance of, and the name. That's okay. That's a little bit of a lot of functions, but first we need to deploy this to Sepolia testnet, right? This contract. Otherwise, the contract doesn't exist in Sepolia yet, so we need to change this to injected provider. Then we can see that now we are connected to Sepolia, because I have connected my MetaMask to Sepolia here. And I have 0.9 ETH. This is 0.9 ETH. Then I can deploy the contract, JKUAT token, deploy. Other things that you can do, for example, is the access control that we were doing before. Right now, if all of you come here and click in mint 10 tokens, everyone will mint tokens, right? And that's not the ideal in a real world scenario. We don't want that anyone can come to my token and mint tokens. So we can say that maybe only Santiago can mint tokens, and then I can mint tokens to any address. Okay, so this is already deployed. So we can go to Sepolia scan. We can come to my JKUAT address. and we will see that I just deployed a contract 34 seconds ago, contract creation. If I click in contract creation, it will take me to the contract that I just deployed. So always the same thing that I recommend is to verify and publish the code. So we click in contract, verify and publish. Solidity single file, compiler 0.8.0, and MIT license. Remember that we have that here. MIT license, compiler 0.8.0. I'm going to copy the whole code. Continue. Copy here the code. Verify and publish. And now when we come to our contract again, now we can see the contract name, JKUAT token, string name, total supply, balances, and then the ABI to interact with my token is here. Remember that we always need to use the ABI. I have a question, guys. Do you prefer that I do a React app or just like scripts in JavaScript? Maybe that would be a bit less confusing with the React code. What do you prefer? Scripts? React? React? Okay, someone wants the scripts? Only scripts in JavaScript? Okay, who wants React? Okay, let's do React. Perfect. So please stop me if you get overwhelmed, because React just has like a lot of things and I don't want you to be overwhelmed. Okay, so we have this React app that I'm going to run right now. npm run start. Okay, and we have this so far. I'm going to delete some of that code in the app. This. Perfect. And then to make it easier, yeah, I will put 6 buttons, and every button will interact with one function to make it, just faster. Get name, get total supply, get balance of. Let's put it like this. So these are the 3 reading functions that we have. I think we have one more. Oh no, yeah, those 3: balance of, name, and total supply. And then the writing functions: burn, mint, and transfer. Burn 10 tokens. Burn 10 tokens. Transfer 10 tokens. Okay, so far I just did this. Oh, let me just put that here, maybe. Yeah, get name, get total supply, get balance of, mint 10 tokens, burn tokens, transfer 10 tokens. Now I will create this name here. Maybe let me create a use state for everyone. Use state. Name. Okay, let me create also 6. Total supply. Set total supply. Name to supply, balance of. Set balance of. And then that's it. Name, total supply, and then okay, so far what I did is I created six buttons that you see here. The first 3 will interact with reading functions: one to get the name of the contract, one to get the total supply of the contract, of the token, and one to get the balance of a specific address. And then here we have the other writing functions. Do you have any questions so far with this part of the React? Okay, perfect. And then I just created the states here too. So now let's use web3.js. So what we need to do first is to install the web3 library, npm install web3. Now we check the package.json. We have the web3 library here. Remember that when we want to interact with contracts, we will need the ABI. So I will put ABI of my token.mjs. Then const ABI equal. And then we can find this ABI in two places. The first place is the block explorer. When we verify the contract, we can have the ABI here. Or in Remix, we also have the ABI in the compiler. We have the ABI here that we can copy paste. But then I will use the one of the block explorer. I just copy the ABI. I paste it here. So this ABI will tell JavaScript the different functions that we have in the contract: burn 10 tokens, bin 10 tokens, name total supply, etc. Then export default ABI. Any questions so far? I just installed the web3 library in the package.json, npm install web3, and I just copy paste the ABI of my contract here. No questions? Okay, let's continue then. Then we need to import the web3 module and the ABI of my contract. So to import the web3 is import, don't forget, really important, curly braces, uppercase W, web3. This is something for you to not forget this. Import web3 from web3. And this second web3 is lowercase everything. I guess you will not forget this line number 5, because that's the key of everything, and if you do this one wrong, you can get other errors. And then import the ABI. Where is the ABI? Let's see. Oh. Yeah. So we are importing the web3 library and the ABI. I haven't done anything else, so I think these two lines are clear, right? Perfect. Now, let me just put the comment. Use state. We need to initialize the web3 library with window.ethereum. Remember that will be MetaMask to kind of tell the library connect to the MetaMask network of the user. So we need to type new web3 and then window.ethereum. But then we need to store this in a variable that I always call web3 in lowercase, but you can call this whatever you want. Let's say if I call it JKUAT, then we will need to interact with jquat.eth.contract, right? But then if I call it web3, it will be just easier. Just for you to know that it doesn't matter the name that you put there to initialize the library, you will need to use that one. So I just initialized the web3 library to interact with the injected provider, which is MetaMask, in the browser of the user. So that's why we put this window object that is window.ethereum. That's how we initialize the web3 library. Then we can initialize the contract. Let's press here, contract instance. So I can call it my token, or my token instance, equal to new. Then we call this web3 that is here, web3.eth.contract. Then when I put the parentheses, you will see that this gets a contract ABI and then the contract address. So the ABI is this one, ABI, and then the address is here in Sepolia. Okay, before I continue, any question with these two lines, with the 15 or 18, to initialize the web3 object or initialize the contract? Perfect. And now we can use the contract instance to interact with the contract. So I will create functions for the three reading functions: get name, total supply, and get balance. So a same function, get name. Just doing it a little bit fast because it's already like 3:30, and get balance off. Okay, and then every button will call a function there. On click, get name. On click, get total supply, and on click, get balance off. Simple. So far I just put this on click to every button so they can interact with these three functions here, right? And then we need to make the calls to every function in the contract. And to make those calls, what we need to do is to type the contract instance. In this case, I call it my token instance. My token instance dot methods dot the method that I'm calling. In this case, the method that I'm calling is total supply. That's the name of the function. So total supply dot call. Any question with this one so far? This is always the structure that we need to use, like contract instance plus methods plus function name plus call. The plus is the dots, but instead of the plus is literally contract instance dot methods dot function name dot call. Perfect. Then we can do the same here, and we can do the same here. But instead of putting total supply, we are putting name, total supply, and balance off. Yeah, these names of these functions are in the smart contract, so we can see that it's balance off, name, and total supply. But we can see that the balance off will receive an address as a parameter. So I will just hardcode an address here. Address. And I will just put my JKUAT address. Okay, so this is how we interact with the reading functions. Is this part clear of the contract instance dot methods dot function name dot call? Is that part clear? Yeah? Perfect. Now let's try this. We can store this here, result, await, and then we can show this in the front end by calling this set name result. Then in the total supply comes result, set total supply result. I think this will return a number, but let's see it to a string. So let's put it like this. And then the same here, const result, wait, and then let's update the front end, set balance off, result to string. Okay, so now let's go to the dApp and let's see if this works. First I need to check that I am in Sepolia, otherwise this will not work. If I click in get name, we get JKUAT token. If I click in total supply, we have 0, we haven't been tokens yet. If I click in get balance of my address, I hard-coded my address there, is 0 as well. So any questions so far with interacting with the reading functions? Remember that these reading functions don't require any funds. We are just fetching information in the blockchain. Now we need to interact with the minting 10 tokens, burning 10 tokens, and transferring 10 tokens, which gets a little bit more code. But yeah, we can do it too. So no questions so far? I don't want you to be lost and then continue, but let me know and I explain again. Let me just walk through this again. Remember, import web3 and ABI of the contract. Initialize web3 with window.ethereum. Then we initialize the contract by typing web3.eth.contract. We pass the ABI and the contract address, and then we can interact with this contract instance by typing my token instance dot methods dot name dot call. Then same here. Okay, so this is the reading functions. Okay, now let's do writing functions. So we have burn, mint, burn, and transfer. So for this mint, let's first connect the buttons as well. I'll click. Okay, this mint, burn, transfer. Okay, so for the mint, we need to interact with the contract again by typing my token instance dot methods dot mint 10 tokens. I think that was the name of the function. Yeah, mint 10 tokens. Then dot send instead of dot call. And then in the dot send, we need to specify which account is sending the transaction. Let's put sender here. But then to do this, to get to this sender, that's where we need to pop up MetaMask to ask the user, hey user, connect the account from where you wanna interact with the contract. So then that's why I'm going to create a new function, which is connect accounts, or let's say request accounts to the user. And this request account to the user will ask the user to connect an account by typing web3.eth.request accounts. MetaMask will pop up, and then this will return an array of addresses. And then we can return the array of addresses here. But I will console log this so you are able to see what's happening here. What I'm going to do is that I will not create a button for this function, but I will actually call this function in every writing function, so you will see what happened. So if I call, for example, the burn right now, we are only calling this function of the request accounts. This is just for testing to see if this function is working properly. Let's see what's the error. Oh yeah, sender is not. Okay. Let me just disconnect my account. Okay, so if we click this one still works. Then if I click in mint 10 tokens, this will ask me to connect an account. It's just connecting the account. Then if I connect the account, and then I check my console, it shows this array of accounts. Is this part clear of the request accounts to the user? Basically what we did is just pop up MetaMask to ask the user to connect one account, so we have access to that address that is here, because this address will need to be here as the sender of the transactions. That's why we need to connect the accounts. So is this function clear? Request accounts to the user. Perfect. Then let's see what this returns. Hopefully it's returning an account. I will just console log account return. And then let's see what happened. When I call the mint, this should return this account. So let's see what happened. Yeah, account return is this one. Perfect. And then we will need to access only to the index in the position 0, in the index 0. Yeah, and then this is the string that we need. This is the string that we need here. Accounts 0. So I don't know if this, I can go through this again if any of you have like any question with this account process here. What I did was to ask the user to connect the accounts by calling web3.eth.request accounts. This is an array of accounts that will be here, and I'm just returning that array because I'm calling this function here again. I'm accessing to the array here, and then just getting the account number 1, like in the index 0. that is sending this transaction interacting to mint 10 tokens. Any questions with this? No? I can go through this again. I don't have any, I'm not in a rush. I can try to explain different. I want you to actually be able to understand this. So yeah, don't be shy. Perfect. Okay, so we can basically do the same with the other ones. Let me just copy this. We are just requesting the user to connect the accounts. If the user already connect the accounts, then the MetaMask will not pop up. This will just return the account that is connected right away. And then here, instead of mint 10 tokens, is burn 10 tokens. .send, and then the same account. So this is basically the same code as you can see, but here we just change the name of the function, and then here still the same thing here, the .send. And then in the transfer is a little bit more tricky, because the transfer, remember that will receive, if we check here in the code, the transfer will receive an address that will be the address of the receiver. So for this example, I'm just going to also hard code another address that I will call receiver. I'm going to create a new account that I will call receiver, and I will put the code here. I will put it here on top. Const receiver and const JKUAT. Remember that this JKUAT is the account that I created like 4 hours ago. JKUAT. Okay, because I just want to hard code the balance of and the transfer. So for the transfer, we are sending 10 tokens to the receiver from the JKUAT. And then for the balance of, I'm going to do two things. One to show the balance of the receiver, and one to show the balance of JKUAT. So you can see if what's going on. Balance of JKUAT and balance of receiver. So in this case, I will delete this. So I'm interacting with the contract, my token instance.methods.balance of JKUAT and receiver. Remember that are the addresses that I have here. And then we can show this in the front end too. So balance of JKUAT, balance of receiver, yeah, and then let's put the buttons again. Balance of receiver, balance of JKUAT, any questions so far with this double function that I did? Just want to show the balance of the JKUAT and one of the receiver. Oh yeah, so balance of. Where is the error here? Oh yeah, balance of JKUAT and same balance of receiver. And now balance of is not defined. Balance of. Where's the balance of here? What is this line here? Balance of is not defined. Where is the balance of? Are you able to spot the error here? Where's the balance of? Okay, we need a React master to help here. Who is able to find an error here? Balance of is not defined. Where I have the balance of? Someone is able to find the error here? Or yeah. Where do we have balance of? Which line? This one?
But when you declare the state for balance of JKUAT, I think that is what you're accessing.
But do you think the error is with this one?
Yeah.
That I'm not showing that. That one is this one.
Oh, okay.
And then this one is this one too. What can be the balance of issue? Let's. Oh, we just need to refresh. Okay, we learn more every day. So there was no errors. You just need to refresh. So, name, total supply, balance of JKUAT 0, balance of receiver 0. If I mint 10 tokens, the account that will be connected is the JKUAT account. Oh, but then once this is, I want to do something automatically. So once we mint, and once with this transaction is done, so I will add this await. I want to set balance of JKUAT. Actually not, to get balance of JKUAT. So once we mint, we are going to call the get balance of JKUAT here, and then this will update the front end of the balance of JKUAT and also the balance of receiver. Let's just add those two everywhere. So every time that we mint or that we burn, that we transfer, we are just updating all the balances. Okay, now it's a lot of code. Now it's a lot of code, but this should work. Let's try. Let's see. Wow. Okay. So we are minting 10 tokens from the JKUAT account. You see here. Confirm. If everything goes well, we will see here at 10 soon. Ah, we got it. Okay, that's good. And then actually we can also update the total supply. I forgot to update the total supply. So get total supply. So every time that we mint, we also update the total supply. And transfer as well. So now our total supply is 10. Balance of JKUAT is 10. Balance of receiver is 0. If I transfer 10 tokens, remember that this transfer is already where is it? This transfer is transferring to the receiver. I hard coded the receiver address 10 tokens. So if I click in transfer 10 tokens, we got an error. Okay. Oh yeah. Who can tell me what is the error here in this function? That's a hard question. Who can tell me that? Okay, $10 to the person that answered that question. That's a hard one. I mean, yeah, it's a really hard question. I will give you 1 minute if you are able to find the error. The error is saying that my token instance .methods .transfer is not a function. So the error is here in line 70. Who can tell me why? You have until 3:44. If you have the answer, please raise your hand. Anyone can participate.
It is not in our contract.
It's not in our contract. What?
The transfer.
The transfer function. Okay, this guy got the $10. Yeah, so I'm calling .transfer, but remember that transfer is called transfer 10 tokens. So that's the error, that we are calling a function that don't exist in the contract, and it's called transfer 10 tokens. And this is the beauty of the ABI. So the ABI is actually not allowing us to interact with the contract because that function doesn't exist. Because if you go to the ABI that we have here, and I just put transfer, you can see that transfer doesn't exist. It's only transfer 10 tokens, the name of the function. Perfect. Okay, we will give you that at the end of the workshop. Transfer 10 tokens, and now that should work. So if I transfer 10 tokens, and then I click confirm, hopefully all this beauty will be updated soon. Balance of JKUAT is 0, balance of receiver is 10. And total supply is still 10, because we didn't mint anything. If I mint again, then the balance of JKUAT will be 10, balance of receiver will be 10. Let's just mint to show you. And then I will transfer again. And then this will update automatically. It will be 20 here, 10 here, and 10 here. Yeah, 20, 10, 10. Then if I transfer again, and every time that I'm doing this, I'm spending money in gas fees. Now it will be 20, 10, 20, 0, 20. And just for you to have an idea, I had something similar to this in my portfolio when I got my first job in Web3. I was doing something like this. 20, 0, 20. It just had like a little bit more complexity when I have like this on my portfolio. I have something like that, but it was a ERC, it was a token that has 6 different tokens, and then you have token 1, 2, 3, 4, 5, 6, and you can mint token 1, 2, and 3. But then to mint token 4, you need to burn token 1 and 2. To mint token 5, you need to burn token 2 and 3. And to mint token 6, you need to burn the 3 tokens. So I did a simple dApp like that. So that shows like, okay, this guy knows a little bit about smart contracts. He's able to show this in a front end. So yeah, I'm just giving you some ideas of on advice of what I did. And yeah, and then if I burn 10 tokens, this will not allow me to burn 10 tokens because this burn is coming from JKUAT, and JKUAT has 0, right? And remember that I cannot burn if I don't have any. So what can I do is that I can mint 10 tokens, and then I will burn it, at least to test that the burn function works. Let's just get everything here, name, total supply, balances. Okay, now it's 30, 10, 20, and then if I burn, it will be 20, 0, 20. Hopefully. Okay, that didn't work. Let's see what happened with the burn. Oof. Okay, there is an error. Maybe there is an error with the contract. We did that wrong. Let's see. Now, as you can see, we have all these interactions that we just made from the dApp. This mint 10 tokens, transfer 10 tokens, mint 10 tokens, transfer, mint. But there is not the burn. Oh, it just burned. Okay, the burn just took a little bit longer, but it burned already. So 20, 0, 20, and then we should have the burn here as well. Soon, really soon. Okay, it's slow. But we should have the burn. Okay, perfect. So now we interacted with all the functions. Here was the contract creation 34 minutes ago. Then 6 minutes ago, mint, transfer, mint, burn. And everything from this React app. And yeah, open to questions. Do you have any questions? That's basically everything. I will publish this in Twitter and repo. I created this folder called JKUAT, and then in the JKUAT I have message contract, which was the first dApp that we did in the morning, and then the tokens, which is this dApp that we just did. Also, let me just put here like a contract, my token.sol, just for you to have the solidity code as well. Maybe here in the README token address, and then I will put the link to this Sepolia contract. And what else? And here I think I have the same. token address. Oh, you know, I will show you the last thing that this will be a mind-blowing moment. You can go to flick.xys, and then we can publish this dApp, and then I will be able to show you the link, to send you the link to this, and then you can mint tokens and do everything from your computer. But let me just update first the README, because when we create dApps, I don't want to have an interview to show a recruiter, oh yeah, look, go to my GitHub and then you can run this in the local host and then you can check my app. No one will do that. So then if we deploy that in Vercel, something like that, that will be the best way to do it. But let me just update something here in the README. Any questions so far? Can answer some questions if you guys have. Yeah. A what? Ban. And what will be a ban function? That address cannot mint or cannot burn? Oh, wait, a little bit higher, please. Louder. How we implement it? A ban function. But what will be the idea of the ban? That a banned address cannot do anything with the contract? Or what do you want to do with the ban? What? Oh, you just want to see me writing that? Yeah, I can do it, but yeah. Okay, just give me a second here, and yeah. Do you want to create, just to double check, you want to create a ban function that, wait a minute here, a ban function that will check if an address is banned, cannot mint tokens. That's what you mean, or what do you want? Because I don't get the ban thing. Oh, the burn function. Oh, okay. I understood to create a ban, B-A-N. No, you mean this burn function, burn 10 tokens. Oh, okay. So first we have the mint 10 tokens. So the mint tokens, do you remember what is the mapping? The mapping is just this key value pair of addresses and uints. So address 1 has 0 tokens and address 2 has 0 tokens. So when we call the mint, what we are doing is just saying address 1 has 10 tokens, right? That's the mint. Has the current tokens that they have plus 10. That's what we have. Okay, wait. Have some technical issues here. Thank you. And then what the burn function will do is we'll say this address 1 minus equal 10. So here we are just updating the balance, adding 10 in the mint, but then in the burn we are just reducing the balance by 10. So that's burning, reducing that, and then until you get to 0, it will not allow you to burn more. Is that answer your question? Perfect. Thank you. Thank you for the question as well. Any other questions? Perfect. Okay, so now I will come to Flick. But first I'm going to push the code. I'm going to push this code on my repo. So let's call it JKUAT workshop. And let's see, I hope I don't get issues with this. I don't know if this will work, but let's see. I always have issues with GitHub. Okay. Okay, so supposedly, yeah, but we have an issue here because this is a sub-module, and I don't know how to fix this. This is so complex. So let me try to do something else. I just want to push this to GitHub, but I'm struggling with this. So let me create a new repo. JKUAT Workshop 2. Then let's see if I can push this. Okay, maybe it works. Okay, perfect, it works. So in JKUAT Workshop 1, I have, could I make a mistake with the folders? So in JKUAT Workshop 1, I have this. I have this whole thing with the 2 folders of message contract. That was the first dApp, and then tokens. But then in JKUAT Workshop 2, I have only the dApp that we just made, like this one. So this is the one that I will need to access. We need to change something in the package.json, and we need to add something called homepage equal to dot to be able to deploy on Flick. Then if we come to Flick, you create an account, you log in, you click in deploy your site. And then you will click in add new, deploy my site. I'm connecting to GitHub. This is accessing to some repositories that I already give permission, but in this case I need to add the JKUAT Workshop 2, where the place that I have my app, my React app. So here we see all the repos that I'm going to give access. So JKUAT Workshop 2, where is the place that I have my React app. Save, to give permission to Flick. Now here we will see the JKUAT Workshop 2 deploy. This will check that the automatically is a React app. We leave it like that. Deploy site. Just close this. Yeah, now it's deploying. So it will take maybe like 1 minute. And we will have access to something like this, but in a live link, and also in IPFS. Who is familiar with IPFS? Or who is not familiar with IPFS? Okay, that's the right question. So IPFS is called Interplanetary File System. That interplanetary file system allows you to store information kind of in the cloud, but it's called an interplanetary file system. So that's decentralized in case that you want to deploy your front end. That's a really good place to go. And Flick is also deploying your dApp, in this case your front end, your React, to IPFS. So this link that I will send you here will be there forever, and this dApp will be there forever too. But yeah, so hopefully this should work soon. And then the smart contract will be there forever too. Yeah, flick.xyz. Now let's just wait. Okay, it's deploying. It's still deploying. Any questions so far? Everything is clear? After this deploy, I think we are done, and then we need to run away from the place. Yeah, so no questions so far. I will publish everything on my Twitter, like the video. This is a long video. This is 2 hours and 50 minutes video. Remember that after 1 hour and a half, we started with the tokens. And it's still deploying. close this. Okay, it works now. Got the email. Okay, so now we have this link. So you can go to shallowbearmelodic.onflick app, and then you will see that my app is not. Oh, I didn't push the changes, I guess. Oh yeah, I didn't push my changes. That's why we just have the React app. Oh yeah. Okay, little thing. I didn't push everything. Yeah, so as you can see, this React app is already live here in shallowbearmelodic.on.flick.app. I just need to push the changes because I just pushed the first React app. Now I push it. Yeah. Now I just push the changes, so this should update soon. And yeah, and that's basically, this is the link that you can include in your portfolio, and then the recruiters can go here and then they can see, hey, okay, this guy is doing this and that, and yeah, that's how we interact with contracts. That's how we deploy dApps and everything. So I think that's everything for today. You can visit this link and then you will see the dApp working there. And yeah, if you don't have any questions, then we can finish for today. You can send me messages on Twitter. I'm going to publish the slides, the videos. This is my Twitter, Santiago DevRel. I will publish everything there tonight. Yeah, we'll try it tonight. I just wanted to check if this was able to refresh. Yeah, but not yet. Redeploy. Yeah, so I think basically we are done for today. Thank you so much for coming, guys, and yeah, I hope you learn new things today and can deploy dApps too. Thank you. It should work. Gideon. Did you learn a lot?
Yeah, I am.
Are you going home? At my computer.
I really understand those are
Yeah. That's true. I just wanted to see if this should deploy.
You think I'm going home?
I think I'm going to Web3 clubs. This shit's slow. Oh, the internet's not working now. Oh. Anyway, it's
So you put the Chrome in Spain. I was wondering the same thing as screenshot someday.
Oh, that's Portuguese. I don't know. It's in Portuguese because I was in Portugal.
Do
Yeah.
you understand?
Portuguese. Yeah.
I don't know English, Swahili, and
That's
my
good.
native language.
That's good.
I don't know.
Hey, we'll see you. Thank you. Thank you so much. We'll publish everything. Shit didn't work. It's fine. I just wanted to check that it's deployed. Yeah. You can take the banner with you. You can take it over. I will also send you the money for the Uber.
From here to my home place, it's just
It's fine. I can take the Uber. Go with the banners.
Yeah,
I don't want to walk with two banners like that. But from here to the fucking gate is like 2 hours walking.
I've been used to it because of studying yesterday.
That's too much. It's never worked. Oh, I need to stop this.